Hi and welcome back, third part of the trigonometric video functions. Now that we understood where do these values come from, where does the nature of sin and cos come from with the trigonometric circle, we're going to proceed to graph the charts, okay, of all trigonometric functions, starting of course with sin and cos, which are the base for the rest, okay? And again, I have drawn the trigonometric circle to explain one more thing, okay? With sin and cos, there's something that is very particular in the trigonometric circle. Remember that the last value that we calculated was 90 degrees, right? And that was when the trigonometric triangle was all the way up here, okay? This angle right here is 90 degrees, okay? But what happens if we calculate 91, 92, or 120 degrees? Well, in that case, the triangle goes all the way to the second quadrant, okay? It goes all the way this way. Okay, because the alpha angle is just now counting this distance from here, from the x-axis to the, other part of the triangle. Okay, it's not precisely the alpha that is pointing in the inside of the triangle, but just the entire distance of, like, the clockwise distance. Okay, so you were wondering something like, well, if alpha is 120, well, maybe sin of 120 can be 2 because the number is bigger. No, that's not accurate at all. Why? Because it doesn't matter where you move around the trigonometric circle. You can be at 120, 160, 155, 180 degrees. You can be at 200, 210, 270 degrees. You can be at whichever degree you want. The distance between the center of the circle and any point contained in the circle is always 1. So the maximum distance that x and y can get is 1. Because the maximum distance x and y can get is when they are either at 0, 90, 180, 270, or 0, 360, which is rounding, circling the circle one time. Okay? That's the maximum distance that can happen for x and y. And let's make a good example. Okay, let's assume, let's think for a second that they're asking me for sin and cos when alpha is 180 degrees. Well, that means I have to give the coordinates of this point right here, or express in other words, express the distance of the triangle when it's all flat right here. Okay, so what are the coordinates of this point if the trigonometric circle has a radius of 1? What is the coordinates of this point? Easy, right? This is 0. What's this? X equals -1, and y equals, this is 0, this is 0. It's like that. So if x is cos, then cos of 180 is -1. And if y is sin of 180 is 0. And there you go. Because that's where we are in the trigonometric circle. And again, 1 is the maximum value that sin and cos can receive in the trigonometric circle with radius equals 1. Okay? Let's say if we are here, okay? If they ask us to calculate sin of 270 and cos of 270. Well, I'm right here, right? So what's the coordinates for this point? Well, in this case, alpha has been doing all of this. That's the angle, 270. Okay? And the coordinates for this point, well, that's pretty easy. Ratio equals 1. So this distance, maximum at least, is 1. What's x? Well, I'm right here. So the distance in x is 0, because I haven't moved from the y-axis. 0. And y, well, if this is 0, this has to be -1, because I'm -1 steps under the x-axis, okay? So, if x is cos, then cos of 270 is 0. And if y is sin, then sin of 270 is minus 1, according to this. Okay? So again, in the specific case of sin and cos, the maximum value that they can draw is 0 and 1. And they keep flipping around, 0 and 1, and 0 and minus 1, of course, because as you can see, we have a negative value right here. Okay? They keep moving around following this pattern. Okay? When cos is at 1, it starts decreasing. Okay? You can see that if cos is at 1, it starts decreasing. Okay? And eventually, it keeps going lower until it reaches minus 1. And we can even add this right here, okay? Let's see if you can see it. 180 eventually is going to be minus 1. And then for sin and sin. Okay? Now, once cos reaches minus 1, it doesn't mean it's going to go to minus 1.4 or minus 2. No, it's going to go back to 1. See? From here to here, it went up to 0. And from here to 360, it's going to go back all the way up to 1. See? The same applies with sin. The only difference is that sin always starts at 0 because sin of 0 is 0. Sin starts growing, and then it reaches 1. And then it starts decreasing, heading back to 0, and then heading back to minus 1. And once it has reached minus 1, it starts going up again, following this pattern right here. So, the chart is going to look a little bit like this then. And again, you can verify this in your book, and by verifying this, I mean the chart, because I'm not very good at drawing, but I'm getting there, okay? And I want to show you is the nature of where the graph comes from, okay? So if we have a y-x-axis, let's do sin first, and we will do cos next. We know that the maximum value sin is going to get is 1, and the minimum value it's going to be minus 1. Okay? So what we're going to write in the y-axis are those maximum and minimum values, and what we're going to write in the x-axis are the angles. Okay? So let's say we have 30 degrees, 45 degrees, 60 degrees, 90, and then we're going to be a little more aggressive, like 180 right here, and then 270 right here, and then 360. Okay, maybe I should have had a little bit more space. Okay, let's say we have 30, 45, 60, and 90 right here. That's I think the scale is a bit better that way. Now I can move 270 a little bit like this. Okay, so I know that the maximum value that sin is going to be reaching is going to be this area right here, and the minimum value is going to be this area right here. Okay, so we're doing sin. Okay, y equals, or fx equals, or f alpha equals sin alpha. We start with 0, and as we move on the angles, it starts growing up. Going to look a little bit like this. Okay? When we reach 90, we reach the maximum value, and then it starts going down until it reaches 180. Now I can move the 180. Like I said, I'm not very good at drawing, so you have to bear with me on this one. On 180, sin of 180 is 0. And then it goes all the way down, like this. Reaching or bottoming at minus 1, 270. And then it goes all the way up. Okay? Reaching 0, guess where? On 360. Okay? I think I'm going to have to delete this so you can see a little bit better. this purple marker is really strong. Let me extend the x-axis. 270, and then 360 around here. Okay? I need to perfect my drawing definitely. This is the graph of sin of alpha, or sin of x. Now you can do x or whatever variable you want to call. This is the graph of sin. It goes all the way up, reaches 1, then it goes all the way down, meets 0 at 180, then go all the way down, meets minus 1 at 270, and then goes all the way up. And then guess what happens? It becomes periodic, okay? The same pattern starts repeating itself over and over and over again. Why is that? Because sin is inside the trigonometric circle. The maximum value that it can receive in the trigonometric circle is 1. Okay, it doesn't matter what you do, it's always going to be either 1 or minus 1. Okay, so in essence, the chart, and this is a reduced version of it, is going to look something like this. Okay, da 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 da, and then on and on until the infinite. And this right here is minus 1, and this right here is 1. Okay, that's the graph of sin. Now let's do cos. I have a feeling that cos is going to look a little bit like sin. You're quite right. Okay? The only difference is going to be the cut, the intercept with the x-axis. Okay? But the equation, the graph is going to look very, very, very alike. So let me delete it. Remember our table, the one that we deleted here in purple? We should know the values by now, probably. Okay? In the case of cos, well, our starting point is not 0, because cos of 0 is not 0. Cos of 0 is 1. So here's where we start with cos. And then what did we notice at the table? It starts decreasing, okay? Until it reaches cos of 90, and cos of 90 is 0, okay? So it goes all the way like this. Okay? Once it reaches 0, if you correctly recall, cos of 180 was minus 1, okay? So that means it continues decreasing, but then it hits minus 1 at 180. So it goes like this. Okay? And then, once it hits minus 1, because that's the maximum value it can take, it goes all the way back to 270. And cos of 270 is 0. So it goes all the way like this. And then, it goes back to 360, but 360 is equal to 0. So cos of 360 is 1. There you go. And as you may have imagined, figured, it becomes periodic. The pattern repeats itself infinite. Okay? So if we were to graph a short condensed version of cos, it's going to look like this. It starts at 1, and it's going to look like this. And so on. This being 1, and this being minus 1. It's exactly the same as sin, only that it's a little bit more pushed to the right or to the left, whichever you want to see it. But in essence, they're the same. Okay? That's for sin, and that's for cos. The other 4 graphs are going to have a little difference. Well, actually not a little, a very big difference between sin and cos. But you're going to see why is that happening. Okay? Next video, the other 4.